Think back to your school days, science class, your teacher standing at the front of the room, drawing planets on the chalkboard, telling you about the solar system, 9 planets, wait, 8 planets, the sun at the center, gravity holding everything together, light traveling at 186,000 miles per second. You memorized it. You passed the test. You thought you understood space. You were wrong. Not because your teacher lied to you, but because what they taught you was the simplified version, the comfortable version, the version that does not keep scientists awake at night in cold sweats. The real story of space is so much stranger, so much darker, so much more terrifying, that if they had taught you the truth in school, you would have never slept again. Today we fix that. Today we teach you what school never did. And I promise you, by the end of this video, you will never look at the night sky the same way again. Welcome back. Let me ask you something honest. When was the last time something about space genuinely shocked you, not just impressed you, not just made you say, wow, that is cool, but actually stopped you cold, made your heart beat faster, made you question everything, made you feel genuinely small and confused about the reality you inhabit? If you are struggling to remember, that is not your fault. It is the fault of how space science gets taught to most people. We get diagrams. We get memorizable facts. We get comfortable stories that package the universe into something manageable and friendly. But the real universe is not manageable, is not friendly, is not comfortable. The real universe is violent, ancient beyond imagination, filled with phenomena so extreme they break our intuitions completely, operating on timescales that make human history look like a single heartbeat. Today we are going to cover 7 things about space that your school textbooks completely ignored. 7 truths that scientists know, that researchers study, that papers get published about, but somehow never make it into the classroom where they belong. So, consider this your real space education. Class is now in session. Let us begin. Lesson number 1. Every single diagram of the solar system you have ever seen in a textbook is catastrophically, embarrassingly wrong. Not slightly off, not approximately correct, completely and totally wrong. Here is what I mean. Open any school textbook. Find the solar system diagram. You will see the sun on the left side, then Mercury close by, then Venus, then Earth, then Mars, then a small gap, then Jupiter, Saturn, Uranus, Neptune, all neatly arranged, all relatively close together, all fitting on one page. Now let me show you the reality. If you shrunk the sun down to the size of a white blood cell, just one single white blood cell, the nearest star to our sun, Proxima Centauri, would be roughly 2.1 kilometers away from that white blood cell. 2.1 kilometers. But we are not even talking about other stars yet. Let us just stay in our own solar system. If the sun were the size of a basketball, Mercury would be a grain of sand sitting 36 meters away. Earth would be a small marble sitting 93 meters away. Jupiter would be a golf ball sitting 484 meters away. And Neptune, the last official planet, would be a small marble sitting 2.8 kilometers from the basketball Sunday your textbook showed Neptune maybe 10 inches from the sun on the page. The reality is 2.8 kilometers. And here is what makes it even more extreme. The solar system does not end at Neptune. Beyond Neptune lies the Kuiper Belt, full of dwarf planets and icy objects. Beyond the Kuiper Belt lies the scattered disk, and beyond that, in an almost unimaginably distant shell surrounding our entire solar system, lies the Oort Cloud, a vast spherical cloud of comets and icy bodies extending from roughly 2,000 AU from the sun, all the way out to possibly 100,000 AU. 1 AU is the distance from Earth to Sunday, 93 million miles. The Oort Cloud extends 100,000 times that distance. In our basketball model, the Oort Cloud would extend roughly 1,500 kilometers from the basketball, from New York to Chicago. That is our solar system. Not a cozy little diagram on a page. A vast, almost incomprehensible bubble of space, so enormous that even light takes over a year to cross it. And between us and the next star system, nothing. empty space on a scale that your textbook never once tried to convey. Why does this matter? Because understanding the true scale of space is the foundation of understanding everything else, and we have been teaching it wrong for generations. Lesson number 2. The sun is not the friendly yellow circle your textbook drew with a smiley face. The sun is a violent, unstable nuclear furnace actively trying to destroy life in this solar system, and the only reason you are alive right now is a magnetic shield you cannot see, cannot feel, and probably never learned about properly. Let us start with what the sun actually is. It is a ball of plasma 1.4 million kilometers wide. At its core, temperature reaches 15 million degrees Celsius. Every single second, the sun converts 600 million tons of hydrogen into helium through nuclear fusion. Every second, 600 million tons, gone, converted to pure energy. And it has been doing this for 4.6 billion years. But the sun is not just a furnace. It is an active, violent, explosive system constantly ejecting dangerous material into space. Solar flares, sudden explosions of radiation from the sun's surface. The largest ever recorded, the Carrington event of 1859, was so powerful it set telegraph machines on fire, literally caused sparks to jump from equipment, created aurora borealis, visible in the Caribbean. If a Carrington-level event happened today, every satellite in orbit, destroyed. GPS, gone. Internet cables, burned out. Power grids across entire continents, fried. Modern civilization, effectively ended. We would be without electricity for months, possibly years. While we try to replace transformers that take 18 months to manufacture under normal conditions, that is not science fiction. That is a documented risk that NASA and governments quietly prepare for. But solar flares are just the beginning. Coronal mass ejections, CMEs. These are billion-ton clouds of magnetized plasma hurled from the sun at speeds of up to 3 million kilometers per hour. When aimed at Earth, they hit our magnetic field like a hurricane hitting a coastal city. Our magnetic field deflects them, distorts, stretches, struggles. Without that magnetic field, the CMEs would strip away our atmosphere. Molecule by molecule, over millions of years, this is exactly what happened to Mars. Mars once had a magnetic field. Mars once had a thick atmosphere. Mars once had liquid water on its surface. Then Mars's core cooled, magnetic field died, solar winds stripped the atmosphere, water evaporated into space. Mars went from potentially habitable to a frozen desert, all because it lost its shield. Earth still has its shield, but the shield is not permanent. Earth's magnetic poles flip every 200,000 to 300,000 years. During the flip, the field weakens dramatically, sometimes drops to 10% of normal strength. We are currently overdue for a flip. The magnetic field has weakened 9% in the last 170 years. What happens to life during a weak field period? Increased radiation reaching the surface, higher cancer rates, damaged electronics, potentially catastrophic for technological civilization. Your school taught you the sun gives us warmth and light. True, but it also gives us radiation, plasma bombs, and a constant existential threat that only our invisible magnetic shield prevents from ending all life on Earth. That seems worth mentioning in class. Lesson number 3. Everything you have ever seen, everything you have ever touched, every star, every planet, every galaxy, every human being, every atom of matter in the entire observable universe makes up less than 5% of everything that exists. Less than 5%. The other 95%, we have no idea what it is. Let me say that again more clearly. 95% of the universe is made of substances and energies so unknown to us that we invented placeholder names for them. Dark matter, dark energy, dark not because they are sinister, dark because we cannot see them, cannot detect them directly, cannot touch them, weigh them in a lab, or explain them with our current physics. Let us start with dark matter. In the 1970s, astronomer Vera Rubin was studying how galaxies rotate. According to normal physics, The outer edges of a galaxy should rotate slower than the inner parts, just like the outer planets of our solar system move slower than inner ones, but they do not. The outer edges of galaxies spin at roughly the same speed as the inner parts, as if there is extra mass, invisible mass, holding the outer stars in place with extra gravity, like an invisible scaffold holding the galaxy together. This extra invisible mass is dark matter. It does not emit light, does not reflect light, does not absorb light, does not interact with normal matter at all. It only interacts through gravity. And it exists in enormous quantities. For every gram of normal matter, there are roughly 5 grams of dark matter. It is everywhere, around every galaxy, filling space in vast halos we cannot see. Right now, dark matter particles are passing through your body, through the Earth, through the Sunday, without interacting with any of it, like ghost matter permeating everything. We know it exists because of its gravitational effects, but what is it? We genuinely have no idea. WIMPs? Weakly interacting massive particles? Axions? Sterile neutrinos? Primordial black holes? Every candidate has been searched for. Most have been ruled out. We still have nothing confirmed. Then there is dark energy. Even stranger. In 1998, scientists studying distant supernovae expected to find that the universe's expansion was slowing down due to gravity. Instead, they found the opposite. The universe is not slowing down, it is speeding up, accelerating outward. Galaxies moving apart faster and faster. Something is pushing the universe apart, some energy built into empty space itself. A repulsive force operating at cosmic scales. We call it dark energy. It makes up 68% of everything in the universe. And we know almost nothing about it. Your school taught you that matter and energy make up the universe. True, but only if by matter and energy you mean the tiny 5% slice we actually understand. The other 95% is a complete mystery. And anyone who tells you science has the universe figured out has clearly never studied cosmology. Lesson number 4. You probably learned about black holes in school, maybe a sentence or two. Stars collapse, gravity so strong light cannot escape. What they did not tell you could fill a library, and several of those facts will genuinely disturb you. Let us start with what a black hole actually is. When a massive star, more than about 20 times the mass of our sun, reaches the end of its life, it collapses inward under its own gravity. The collapse happens so fast, the density becomes so extreme that space-time itself breaks, literally, mathematically, breaks. The equations Einstein used to describe space and time produce a result called a singularity, a point of infinite density, infinite curvature, where the laws of physics as we know them simply stop working. The singularity is surrounded by the event horizon, an invisible boundary in space. Cross it and you can never return. Not because of a wall, not because of a force field, but because inside the event horizon, all possible paths through space-time lead toward the singularity. There are literally no paths leading outward. Space itself becomes a one-way street pointing toward the center. You cannot turn around any more than you can turn around in time. Now here is what your textbook missed. Fact 1, spaghettification. If you fall into a black hole feet first, the gravitational pull on your feet is stronger than on your head. This difference in gravity across your body stretches you. Like taffy, feet pulled faster than head. You become a long, thin strand of matter. Spaghettified. For small black holes, this happens before you reach the event horizon. For supermassive black holes, you cross the horizon before feeling it. And you would not even know the moment you crossed until it was far too late. Fact 2. Time dilation extremes. Near a black hole's event horizon, time slows dramatically. If you hovered just outside the event horizon for what felt like 1 hour to you, billions of years might pass for the rest of the universe. The universe could live and die while you experience 60 minutes. Fact 3. Hawking radiation. Stephen Hawking discovered, theoretically, that black holes are not actually black. They glow, very faintly, but They emit radiation. Due to quantum effects near the event horizon, particle pairs are created from nothing. One particle falls in, one escapes, the black hole loses a tiny amount of mass. Over incomprehensible timescales, a black hole evaporates completely. The most massive, most powerful objects in the universe slowly disappear into faint whispers of radiation. And when they do, what happens to all the information of everything that ever fell in? This is the black hole information paradox. And it consumed Leonard Susskind and Stephen Hawking for decades. Hawking said information was destroyed. Susskind said that violated quantum mechanics. They debated for 30 years. Susskind won. Information must be preserved somehow, encoded in the Hawking radiation, scrambled but not destroyed. But how? That question sits at the intersection of general relativity and quantum mechanics, the two greatest theories in physics, which completely contradict each other at extreme conditions. Solving it requires a theory of quantum gravity we do not yet have. Your school mentioned black holes as a curiosity, a space fact, a cool thing where light cannot escape. The reality is that black holes are the most extreme objects in existence, breaking our best theories, hiding the deepest mysteries in physics, and we have only just begun to understand them. Lesson number 5. The universe had a beginning. The Big Bang, 13.8 billion years ago. Your school probably taught you that. What your school probably never mentioned is that the universe also has an ending, a slow, cold, dark, inevitable ending. And the timeline of that ending is so extreme it is almost impossible to convey. But let us try. Right now, the universe is in what cosmologists call the stelliferous era, the era of stars. Stars are being born, stars are burning, new solar systems are forming, planets are cooling, life might be emerging across countless worlds. This era will last approximately 100 trillion years. 100 trillion. Our universe is only 13.8 billion years old. The star-filled era has barely begun, but it will end. Star formation requires gas clouds. Gas clouds are being used up, not recycled fast enough. Eventually, the last star will ignite and then burn out, and no new star will form to replace it. The universe goes dark. Then begins the degenerate era. Dead stellar remnants drift through darkness, white dwarfs slowly cooling, neutron stars spinning down, black dwarfs theoretical. This era lasts 10 to the power of 37 years. That is 1 followed by 37 zeros. Then the black hole era. Most matter has decayed. Only black holes remain as significant structures. They slowly evaporate through Hawking radiation. The last black hole evaporates at approximately 10 to the power of 100 years, 1 followed by 100 zeros. And then, the dark era. The universe consists of nothing but scattered photons, neutrinos, and electrons and positrons drifting through expanding darkness. Temperature approaches absolute zero. No more energy gradients, no more useful work possible, no more complexity, no more life, no more information processing, complete thermodynamic equilibrium, maximum entropy, heat death, the most final ending imaginable, not with a bang, not with drama, but with a slow, cold, inevitable silence. An empty universe expanding forever, getting colder, getting darker, getting emptier, until even the quantum fluctuations that once created the Big Bang itself have no energy left to work with. And then, nothing, for eternity. This is the confirmed scientific consensus on the ultimate fate of our universe. Your school gave you a Big Bang, but forgot to mention the inevitable ending written into the laws of thermodynamics. Perhaps they thought it was too dark for young students? Perhaps. But knowing it is true and understanding it changes how you see the night sky. Those stars are not eternal. They are temporary lights in a universe slowly burning down, beautiful precisely because they will not last. Lesson number 6, and this one is not terrifying, it is beautiful. Every atom of iron in your blood, every atom of calcium in your bones, every atom of oxygen in your lungs, every carbon atom in your DNA was forged inside a star. Not our Sunday. Our sun is too small to create most of these elements. but massive stars that lived and died billions of years before Earth formed. Stars dozens of times larger than our sun. They burned for millions of years, fusing hydrogen into helium, helium into carbon, carbon into oxygen, oxygen into silicon, silicon into iron, layer after layer of elements building up inside the star's core like an onion. Until the core filled with iron, iron cannot be fused to release energy. Fusion stops, the core collapses in less than 1 second, and then the star explodes, a supernova, the most powerful single event in the observable universe. For a brief moment, one exploding star releases more energy than our entire galaxy combined. In that explosion, the extreme conditions create elements heavier than iron. Gold, platinum, uranium, all scattered across space. The shockwave travels outward, carrying all these elements with it, seeding space with the ingredients for new worlds, for new life. 4.6 billion years ago, one of these shockwaves rippled through a cloud of gas in our galaxy. It triggered the cloud to collapse. Our sun formed, our solar system formed, Earth formed from the remnants of dead stars. And you formed from the remnants of Earth, from minerals and water and air that were once stellar debris. You are not separate from the stars. You are made of stars. The iron in your blood was forged in a stellar core that exploded billions of years ago. You are the universe becoming aware of itself. You are what happens when stellar debris organizes itself into complexity, into life, into consciousness, into someone who can look up at the sky and recognize the stars as family. Carl Sagan said it best, we are a way for the universe to know itself. That was not poetry, that was science. And no school lesson about space is complete without understanding what we truly are. Not visitors to the universe, we are it. Born from it, returning to it, carbon to carbon, stardust to stardust, 7 lessons school never taught you. The solar system is unimaginably vast, nothing like that tidy textbook diagram. The sun is actively dangerous, saved only by our invisible magnetic shield. 95% of the universe is dark matter and dark energy, completely unknown to science. Black holes break physics itself, hiding unsolved mysteries at their cores. The universe has a confirmed expiration date, ending in cold, dark, inevitable silence. We are literally made of dead stars, children of supernovae that lived and died before Earth existed. And the universe is silent, raising questions about existence itself that we cannot yet answer. 7 truths, 7 things that change everything about how you see the cosmos above you. None of them comfortable, all of them real, all of them beautiful in their own devastating way. The universe is not the safe, friendly, manageable place that fits neatly inside a school textbook. It is ancient and violent and dark and vast and filled with mysteries we have barely begun to touch. And that is not frightening. That is the most exciting thing imaginable. Because every mystery is a door. Every unanswered question is an invitation. Every dark corner of the cosmos is somewhere waiting to be illuminated. The universe does not give up its secrets easily, but it gives them to those who keep asking. So keep asking. So which lesson shocked you most today? Did the true scale of the solar system break your mind? Did the sun's violence surprise you? Did dark matter and dark energy make you question reality? Did the heat death of the universe leave you feeling philosophical? Or did the Fermi paradox silence genuinely disturb you? Tell me in the comments. I read every single one. And here is your challenge. Pick the topic that surprised you most. Research it for 30 minutes. Then come back and tell me what you found. Because the universe rewards curiosity, always. If you want more real science, not the textbook version, not the comfortable version, but the actual mind-bending truth, then subscribe right now. Hit the notification bell, because next week we are going somewhere even your wildest imagination has not prepared you for. Until then, look up tonight, really look, and remember what you now know about what you are seeing. Ancient light from dying stars, from a universe that began in a single moment of infinite density, that will end in cold and silence a trillion years from now, and somehow, impossibly, produced you, standing on a rock, looking up, wondering why. That is the greatest miracle in the universe, and nobody taught you that in school either. Take care, stay curious, see you next time.